Good day everyone. In today's video, we'll be talking about the harmonic function. And please, if you are new to this channel, please do well to like, share, and subscribe. So in harmonic function, we said that if a function f of x and y whose first and second partial derivative exist and are continuous is said to be harmonic if it satisfies the Laplace equation. And the Laplace equation is given as the second partial derivative of the function f with respect to x plus the second partial derivative of the function f with respect to y is equal to 0. So also in complex variable, we also have that if a function f of z which is analytic and is equal to u of x and y plus iv of x and y. The real and imaginary part of this function f of x, f of z is harmonic if the second partial derivative of the real part with respect to x plus the second partial derivative of the real part with respect to y is equal to 0. Then we can conclude that the real part of this function is harmonic. Also, if the second partial derivative of the imaginary part with respect to x plus the second partial derivative of the imaginary part with respect to y is equal to 0, then the imaginary part is also harmonic. So let's take down one question there to illustrate. Okay, let's harmonic solve this problem. The question there says if f of z equals to 2xy plus 4y minus 2x plus I into x squared plus 4x minus y squared plus 2y, show that the real and imaginary parts are harmonic. So this question there is just trying to tell us that we should find the second partial derivative of u and v and add them together to see if we are going to get 0. So first of all, let's write down our u and v. But don't forget that u is the real part, while v is the imaginary part. So it means that u of x and y is equal to 2xy plus 4y minus 2x. And also the imaginary part is v of x and y equal to x squared plus 4x minus y squared plus 2y. So let's start our differentiation. So if you differentiate this real part with respect to x, you are going to have partial u partial x equal to differentiate 2xy with respect to x, you have 2y. Differentiate minus 2x with respect to x, you have minus 2. Also differentiate the imaginary part partial v partial x. Differentiate the imaginary part with respect to x, you have 2x here. Differentiate 4x, you have plus 4. And if you differentiate minus y squared plus 2y with respect to x, you have 0. And also, let's differentiate the imaginary part again with respect to x to obtain the second partial derivative. Differentiate partial u partial x with respect to x. Observe that there's no variable x here, so it means if we go ahead and differentiate it, we are going to have 0. So it means that partial square u partial x square is equal to 0. And also differentiate the imaginary part with respect to x again, we are going to have partial square v partial x square is equal to, differentiate x here, you have 2. So from the real part, let's differentiate the real part now with respect to y. So we are going to have partial u partial y equal to, if you differentiate u with respect to y, you have 2x here, differentiate y here, you have 4. Differentiate minus 2x with respect to y, you have 0. Also, differentiate the imaginary part with respect to y, we are going to have partial v partial y equal to, if you differentiate x square, you have 0. If you differentiate 4x, you have 0. If you differentiate minus y square, you have minus 2y. Then if you differentiate 2y with respect to y, you have plus 2. So also, let's obtain the second partial derivative of partial u partial y and partial v partial y with respect to y again. So differentiate partial u with respect to y, you have partial square u partial y square equal to, if you differentiate y here, observe there's no variable y here, so this implies that we are going to have 0. Also, if you differentiate v here with respect to y, you have partial square v partial y square, partial square v partial y square equal to, differentiate minus 2y, you obtain minus 2. So since we have obtained the first and since we have obtained the second partial derivative of the imaginary and real part, let's add them together and see if we are going to get 0. Okay, but remember, the Laplace equation tells us that partial square u partial x square plus partial square u partial y square must be equal to 0. And also, partial square v partial x square plus partial square v partial y square must also be equal to 0. So let's add them and see what we have. Partial square u partial x square is 0, so we have 0 here. And also, partial square u partial y square is also 0, so we have 0 plus 0, which is equal to 0. From the imaginary part also, we have partial square v partial x square is 2, so we have 2 here. Also, partial square v partial y square is minus 2, so we have 2 minus 2, which is equal to 0. So since the real and imaginary part gives us 0, then we can conclude that the imaginary and real parts are harmonic. So therefore, the imaginary and real parts, the imaginary and real parts are harmonic. So this is everything about harmonic function. So in our next video, we'll be talking about complex integrals. So please do well to like, share, and subscribe. And if you enjoyed this video, please do well to subscribe. Thank you.